Hello, everybody. My name is Darlene, and this is the story of how acetylcholine is synthesized, um, put into vesicles, and also cause a reaction at the postsynaptic membrane. It could be a muscle fiber or another neuron. So here you can see choline is readily available outside of the cell, as well as sodium. So they both come rush in. So choline, sodium open the channel causes choline to come in, and then choline attaches to with acetyl coenzyme A with the help of acetyl transferase and synthesize acetylcholine. So now acetylcholine, which is this little neurotransmitters, form into vesicles. So they don't stay in the membrane like readily floating. They get into vesicles and stay there until their services are needed, per se, in the synaptic cleft. So the vesicles migrate all the way to the membrane. So when they are needed to cause an action, it's calcium washes into the calcium channel. So the elevation of calcium inside of the neuron causes acetylcholine to fuse into the membrane and gets released into the synaptic cleft. So now we get an elevation of acetylcholine into the synaptic cleft, which the acetylcholine attaches to the receptors at the postsynaptic ending and causes an effect. So whatever it is, whether it's a muscle contraction or whatever it does, that's what it does at the postsynaptic neuron or cell. But also, if there's too much acetylcholine here in this synaptic cleft, that can also attaches to this receptor here and causes a negative feedback. It says, oh, we have too much here, it's time to stop the production line. So that there's two effects that happens here when acetylcholine is released here. It causes an effect here. When the effect is enough, there's too much still hanging around, it goes and causes a negative feedback. So telling here not to produce anymore. But what to do with all the acetylcholine that's already in the synaptic cleft? So what happens here, with the help of acetylcholinesterase, this enzyme, it causes acetylcholine to disintegrate into choline and acetate. So these two components, this gets released, and choline goes back. Remember at the beginning when we talked about choline washing with sodium? It goes back and get recycled and can produce the same effect again, and the cycle goes on and on and on. Okay, so now we have enzyme that causes formation of acetylcholine, and also an electrolytes that cause the elevation of the level of acetylcholine. We also have negative feedback that tells the neuron to stop producing acetylcholine, and also we need the acetylcholine at the end to produce its effect. But once that's done, we cannot just let acetylcholine hang around in the synaptic cleft. We just have to make sure we disintegrate. So as you can see, when you take those drugs that are acetylcholinesterase inhibitors, so you can see how they create their action here. They could either block these receptors here from receiving acetylcholine altogether, or they can just disintegrate the acetylcholine into this can stop acetylcholinesterase from disintegrating acetylcholine into choline and acetate. So what you will get when you take an acetylcholinesterase inhibitor, you'll get an elevation of acetylcholine here in the synaptic cleft, as well as an abundant amount of it rushing to the cleft that is not being disintegrated or turned into choline and acetate. So this is my take on acetylcholine receptors. Also, just remember that we have two kinds. You have the muscarinic and the nicotinic. The muscarinic, we have M1 to 5, and the nicotinic you have two kinds as well. So that's something for a different lecture, because also it tells you which one is ligand gated and which one is G protein coupled. So that way we can explain that in more details. But so far, this is how acetylcholine is synthesized, get packaged, and they get released into the synaptic cleft. It gets synthesized with the help of sodium that washes choline to the membrane to help with the help of the acetyltransferase and produces acetylcholine, and then we put them into vesicles, and when calcium comes in, the raise in the level of calcium causes the vesicles to release acetylcholine in the synaptic cleft, and that has two effects. It goes to the membrane receptors at the other end and produce an effect, or if there's too much, it can also goes to the presynaptic membrane receptor and causes a stop in the production or the release of acetylcholine. And also the leftover in the synaptic cleft gets broken down with the help of acetylcholinesterase into choline and acetate. Thank you for your time, and we'll be doing a different lecture to explain the different kinds of acetylcholine receptors, which are muscarinic and nicotinic.